our exponent n is a fraction. How would this be expressed in radical form? The radical form of 7 to the power of 1/5 is expressed as the 5th root of 7. Similarly, 25 to the power of 1/2 is the square root of 25. In general, if B belongs to the set of real numbers and n is a positive integer greater than 1, then b to the power of 1 over n equals the nth root of b. Students, please simplify the following. Express each of them without fractional exponents or radical signs. It may take some trial and error, but do your best.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello, students. Please compare your answers to these. The fourth root of 81 is 3. The sixth root of 64 is 2. The sixth root of 729 is 3. The cube root of 216 over 27 is 6 over 3, or 2. There are several theorems that will help us to simplify fractional exponents. The first theorem states that for any two real numbers, a and b, and for all integers where n is greater than or equal to 2, a to the power of 1 over n times b to the power of 1 over n equals a times b to the power of 1 over n. We can see that the 25 to the power of 1/2 times 4 to the power of 1/2 is equal to 100 to the power of 1/2. Similarly, the fifth root of 16 times the fifth root of 2 is equal to the fifth root of 16 times 2. Our second theorem looks at the relationship between fractions and their exponents. This theorem states that for any two real numbers, a and b, where b is not equal to 0, and the integer n is greater than or equal to 2, then a to the power of 1 over n over b to the power of 1 over n equals a over b to the power of 1 over n. For example, students, 64 to the power of 1 over 3 over 6 to the power of 1 over 3 equals 64 over 6 to the power of 1 over 3. This can be simplified to say the cube root of 8, which is 2. Suppose that the numerator of a fractional exponent is not 1. Take 3 to the power of 7 over 5. This can be written as 3 to the power of 1 over 5, all to the power of 7. To simplify this, we write the fifth root of 3 to the power of 7. This definition holds true when a is greater than or equal to 0, and p and q are any two positive integers. Students, please use the theorems and definitions to express these notations. Rewrite A and B using radicals. Express C and D without fractional exponents or radical signs.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. How did you do? We will go over the answers together. For A, the answer is the square root of 81 to the power of 3. For B, the answer is the sixth root of 11 to the power of 5. The answer to C is the cube root of 27 to the power of 5, or 243. The answer to D is the cube root of 125, or 5. Students, we have time to discuss one more topic. You have learned to perform 4 mathematical operations: addition, subtraction, multiplication, and division. If you add, subtract, multiply, or divide 2 rational numbers, you get a rational number. The only case where this is not true is if you divide by 0. This means that the set of rational numbers is closed with respect to these operations. Let us look at one example of division performed on radicals. Suppose we want to divide 12 times the square root of 6 by the square root of 2 times the square root of 3. Since our radicals behave as we expect real numbers to behave, our denominator becomes the square root of 6. When we perform our division, the square roots of 6 cancel out, and we are left with 12 as our answer. Today, we have learned about the relationship between a power with a fractional exponent and its radical form. We have also learned to convert powers with fractional exponents to radical form, and vice versa. Until next time, thank you, teacher. Thank you, students.